Well, good evening tonight, everybody. Welcome to Charlotte IoT. This is our second in our online series. Questions, answers, and projects. We're going to go over some questions and answers. We're going to be talking today about internet communication technologies. Pretty awesome stuff. I know it's a lot of beginner stuff, but I wanted to make sure we talk to everyone in our audience. And believe it or not, there's some things that even I, as a seasoned engineer, don't quite understand. Give me a private certificate store, and you've got me lost beyond belief. So great to have everybody here tonight on the stream. Let's see, Charlotte IoT, we are at 1,943 members, and that's pretty awesome for a meetup group. If we were in person, you would definitely see us, 50, 60, 80 deep in the room, and that's awesome, good times. Unfortunately, I have no pizza for anybody tonight. That's typically part of our meeting, so I hope this craziness gets over quickly, because I could definitely use some pizza and some fellowship. I think everyone could. But until then, we do have the social time before in Zoom. Don't be afraid to join us. We're always hanging out there and definitely having some fun talking about some cool IoT stuff. Anyway, so we are focused at Charlotte IoT here on learning IoT, about talking about IoT, about working IoT projects, helping our community with IoT, and just in general being as awesome as possible. And that's definitely the main thing about Charlotte IoT, is just the amount of total raw awesomeness. So like to thank our board here. Obviously, Dan is our leader, definitely a muse for me. Doing some amazing things out in the IoT field with machine learning. Obviously, there's me there on the list. Mark, maker of things. Graham, Rob, and Christoph. Joseph, who is definitely our live stream guru. He is the one who is definitely helping me out as we started doing live streaming. Mike is our double E and amazing technologist. Glenn, our social media wizard, and Leslie is absolutely amazing at coordinating everything we need and helping us out with some of the menial details that have to be done. So we definitely appreciate everyone on the board. If they're here, I'd ask them to stand up. They're not, so hey. So Charlotte IoT is always looking for different ways that we can bring new and exciting information to our people. And we are going to, we've got this, we posted it out. We can post it out again. You can drop me a link. We can put a link in anywhere for you to look at. But this is a virtual cybersecurity summit. And it's driven towards, really for executives. But let me tell you what, there is nothing better. I can tell you there's nothing better than sitting in a room with a bunch of people that are just 10 times smarter than you, have some of the grace and abilities that we've seen in C-suite type people. And it always is just a really fun event. Sign yourself up, sit in the back of the room. Not only are you going to learn some great information about cybersecurity, you're also going to have the chance to learn how these people are thinking, talking, working the room, and the whole bit. And let me tell you what, that is of such value anyways. So if you need more information about this, let me know. We will post this on show notes. It is coming up here pretty quick. It's this Thursday. But here's the deal. It is free. So no reason why you can't sign up and join us. Thursday, I'll be bopping in for a couple sessions too. I'd like to thank our definitely thank our sponsors. So Pratt Miller has merged with Logical Advantage, and they are the home of IoT awesomeness. They do, we've got the Industrial Revolution 4.0 in manufacturing going on right now. A lot of IoT, a lot of machine learning, a lot of things that are definitely really cool. Doing data analytics, machine learning. They've got a wide suite of offerings. Just one cool little project they've done. This is all humidity control, which if you can imagine in some plants, in some areas, controlling humidity is a huge issue, especially for materials, which maybe, have issues with different humidity levels. So keeping those things straight, making sure warehouses are, of the right environment to keep your product safe, definitely something a lot of people are looking at these days. And just a couple more eye candy shots for all those people out there looking at the cool things in life. Just a reminder that Riot, who is a leader in all things IoT, they are starting their developer month, and that starts September 2nd. Again, we'll put some information in the show notes here, but this is going to be an awesome event. How do I know? I'm speaking in week 3. So you'll see me talking about reliability. For those who don't know, I am a former staff site reliability engineer. I have built reliability from the ground up for $4billion.com. So I tend to think I know a little something about the field. So anyways, enough with the slides tonight. Go ahead and bring it in what we're going to be talking about tonight. Sorry, it's not pretty and cool, but we're going to be talking about TCP/IP protocols. We're going to be talking about how we talk to the internet. We're going to be talking about how we work through pulling and pushing information back and forth. And, there's a lot to this, right? So we're going to start out with some very basic things. We're going to start out with some very basic, protocols. We'll look at the layers. We'll look at all the fun stuff. And let's start here with the layers. And for those who don't know, networking is built on an OSI model, and it's 7 layers. And I know people are like, oh my gosh, not this again. Yeah, this again. So this just kind of puts into play how things work on the internet, right? So everyone looks at the internet, and a lot of people just think it's Google or Chrome. It's a web browser, but, we can put a lot of things over the internet. Internet just means connectivity between places, between things, right? So, and getting those things on board the internet means that those things need to be able to talk to other things, right? So, how we make that work and how we can build that layer upon layer to bring it in is just, there's so many ways to do it, but we're going to talk about one of the most popular ways. We're going to start with a little discussion on UDP and TCP/IP, and then we're going to move on to talking about HTTP or what we'd consider web traffic, and then we'll also touch on a little bit of a couple other protocols, FTP, POP, SMTP, just so you're not going to know what those are and how those operate. So really cool on this OSI model, you're going to see we've got 1 and 2, those are basically your physical layer, right? So if this is going to be where your wiring is. This is going to be where your, you're getting your address, right? And, or getting your hardware addresses, right? So, and this is going to be like the backhaul of your cell phone, or, that connection between your phone itself and the tower, or, the connection between, the controller in your SIM card, the controller on your IoT device that's connected to a SIM card that connects up to this cellular IoT network, or to Wi-Fi, or over a wired network. You know, layer 3 is your networking layer. That's where you're basically looking at, hey, I'm getting my IP address. I'm figuring out kind of how everything's going to mesh together and communicate at that point, right? It's not about the communication itself. It's about how we generate the communication, how we identify ourselves, how we talk back and forth. Think of layers 1 and 2 as like a person, and then layer 3 is like the fact that they can talk, right? The fact that we can have a voice. Layer 4 is where we start talking about how we communicate, right? So this is one of my favorite analogies, is that we can, run through, we can run through the hallways, and UDP and TCP are both ways of sending information over the network. The difference is very easy, right? UDP is when I run through a room and I yell fire. I don't care if anyone's listening. I do, but I'm not listening for them to yell back at me. I'm just running through the room yelling fire, 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 right? Or, if you were my dog, you'd be barking and you'd be barking and you'd be barking, but you're not really listening for a response, right? And then if somebody gets up and follows you out of the room because they know there's a fire, hey, good. If they don't, there's not much you can do, because by the time you've yelled fire, you're out the door and you're gone, right? That's UDP. So by the time you say something, you may no longer, when a device says something, it may no longer be in the position where it can actually respond with anything back. So it may just be pushing messages out there and not caring about, who's listening or what's listening or what they're responding with. And so the advantage of it is it's extremely fast, right? So you're don't have a lot of overhead. It's really, really fast. It's really easy to interface to, right? This is often used for like broadcasting. Some device will say, hey, I'm here, hey, I'm here, hey, I'm here, right? And then your computer will hook up to the UDP and it will say, I'm looking, I'm waiting, I'm listening. And then it hears this guy say, hey, I'm over here, right? And so the computer's listening and they can figure out how they're going to talk to each other. TCP, on the other hand, TCP is hardcore, like get the message there, make sure it got there, make sure it's correct. And if I didn't get it, then I want it back again. So not only is it, hey, this is information that's going out, this is information that it's like me saying, hey, honey, there's a fire. And she doesn't hear me. I'm like, honey, there's a fire. And doesn't hear me. And I shake her. I'm like, honey, there's a fire. She's like, oh, there's a fire. And I said, yes, there's a fire. Well, that's TCP. So that's a request, a response, and an acknowledgement, right? So that's TCP. Now, the cool thing is we can transfer a lot of information that way, because what I do is I say, okay, like in a script, in a book, I can say, okay, this is line 1. Line 1 is, honey, there's a fire. And she acknowledges there's a fire. And I say, yes, there's a fire. And then I say, let's go. And she says, let's go. And I say, yeah, let's go. And then, so then the next one I go, I'm leaving now. I'm leaving. And she says, you're leaving now? What? I didn't hear that. So she's like, what'd you say right before that? I said, let's go. And that's what we call, packet loss. So that original let's go message never got to her. And so we either waited for acknowledgement, didn't come, or the receiver requested that packet over again. They said, hey, what did you just say? How much useful work could be done at the network layer? I think I see where he's going. Okay, so we'll talk about Mikey here in just a moment. So anyways, we have UDP and we have TCP. And those things are really, really, I think, simple. UDP, think of it as I'm going to say something. I don't care who's listening. I'm going to listen for something. I'm not asking for information. So it's a very one-way type of communication. And yeah, it can be kind of distracting on a network. It can overload a network. And there are, in a more advanced network, routers and AP access points and switches and stuff, there is some ability to limit UDP traffic because some things can just be noisy because of bad implementation. So TCP, on the other hand, is very controlled, very, very much. I am sending you information. I want you to acknowledge I got the information. I will acknowledge to you that I got the acknowledgement. And so that's how we send the majority of our information, because it's very structured. It's very, I'm making sure you're actually going to get it. You asked me for a web page. I want to make sure you got it. And I want to make sure that I got that you got it, right? So on top of TCP, we run a lot of different things, right? So we typically run, for example, HTTP, that's web traffic, right? And that's what most people think of the internet as, like a browser. SMTP, that's email. POP3, that's email. SMTP is actually sending. POP3 is one of many protocols you can use to pull email from a server. The interesting thing about the way we send email, I'm not kidding, the majority of email is still sent encoded to only be letters and numbers, so no special characters. It's not actually sent as binary data. Most of emails are still sent in a UU encoded format that actually wastes a fair amount of space. So if you think about it, it wastes about 1/8 of the space used for emails. And that's a lot of traffic if you think about it. But these old protocols have been around for years and we just keep using them. FTP, file transfer protocol, obviously that's for transferring files. You'll often hear it called SFTP, secure file transfer protocol. It's typically done over SSH. SSH being basically a security interface between two different devices. And then we build security, and then on top of the security, we do the FTP file transfer. So it's a way to ensure that that file, the transfer of information, is encrypted from one place to another, which, as you can imagine, is kind of important nowadays, right? So back to what Mike was saying, and Mike is definitely the man. Mike is there is a simpler UDP FTP protocol. It's not really used that much in IoT. It is, but it isn't. It's used in a lot of older equipment tends to use it. Is it still used today? You bet. Anything we've written is still used today. So how much work should be done at the network layer? This is really cool. What Mike is talking about here is we have something called an ARP request, ARP request. What is that? You're like, oh, that's crazy. It's simple. Between when you're looking at giving out a network address, you have two things. You have a hardware address, right? That's the physical address of the device. And then you have what we call typically a TCP IP address, right? So that's the difference between layer 3 and layer 4. The cool thing is we can sit at layer 3 and we can say, do you see this device? Do you see this device requesting information? Do you see this device seeing or making any requests? And this is often an ARP call, which is done to identify the IP address or to send out an IP address for what we call DHCP, Dynamic Host Configuration Protocol, which allows us to basically address things on the back end. And you don't need to know about that. It's kind of little bit outside the scope today, but basically what we're talking about is when a device enters a network, the first thing it normally does is say, hey, I'm here. Here's my hardware address. Let me exchange it for something that is a network address. Well, we can detect that. So that's a really cool thing. You can do a lot with it. Imagine if you come home from work and you have your cell phone, and your cell phone notices you've got Wi-Fi at the house. Oh, Wi-Fi. And so it says, hey, Wi-Fi router, give me an address. I'm here. That has just made a call. It's called an ARP request. And that ARP request, we can watch the network and we can say, show me all the ARP requests. And then we can write a little script that says, hey, when Jeremy's phone makes an ARP request for an IP address, identify Jeremy as being home. I have a good buddy who actually uses this to identify that he is home or that he is not home. So it will turn on and turn off lights inside of his house at his request. That's cool. We also used to hack that back in the day for Tide buttons. So Amazon used to have these little one-touch buttons, right, that order stuff for you. And it was a really cool idea, except it didn't really take off. A lot of reasons why, but one of the things we could do is take that, put it on our network, and then hit the button. And you wouldn't assign it to a product, but you hit the button. You're watching the ARP request, and then you took that ARP request and you pushed it off somewhere else. One of the big problems, though, was a lot of those devices shared the same hardware address. So you couldn't put like 10 on there. You just have all these repeated addresses. You didn't know what button was what, because, yeah. So anyways, back to the topic at hand. We're going to talk about TCP. I think the easiest way for us to take a look at TCP, honestly, is we are going to go ahead and take a look at what exactly is happening for TCP/IP. So let me clear this. And we are going to take a look at a raw. This is a TCP/IP. This is a TCP/IP request, right? But this is not what you're seeing. This is a HTTP request over TCP/IP. This is, however, not what you see on the screen. So what you see here is very simple. Making a connection. We're connecting to google.com. This is telling us what we're offering or what we want. Looking at, this is all certificate information, the types of certificates, the type of security that are available, information about the certificate on the actual server itself. Again, security being a huge part of what we do, this is definitely part of a lot of different requests. You can see down here, we're identifying the host. We're telling it what kind of protocol we're going to use. We'll get into that in a minute. And then we're looking at a lot of stuff here is kind of, I mean, it's not required for everything. This is telling us what kind of protocol we're going to be getting back. And then obviously the location. Content length. This is huge. This actually has to be there. It tells us what the it tells us how long the actual bit of information is. And this is coming across as, hey, this is the information that's being sent to me. This is the actual text, right? So this is HTML. This is hypertext markup language, and this is what actually displays on a this is actually what displays on a on the back end of the web browser. So it's what makes web browsers. We go to something a lot simpler, and this is a great example, right? So we're looking at, this is one of my servers. Yes, I own war operation plan response.com. Yes, I have Joshua at waroperationplanresponse.com. Insert your favorite laugh track there. You can see the first thing we're doing is we're saying we're connecting to a server. And then we're saying we're getting something, and this is where we're getting it from. Identifying the host and the user agent. And then coming down here for a lot of this we're not going to go over. Content type, that's huge. Content length, it's huge. So obviously content length is telling you how big this is, right? The content type, that tells you what it is, right? So this could be text.html. It could be application/JSON. Apparently, I need to make this bigger. See if I can do that. We able to see that? Bigger, bigger, bigger. Is it showing up at all? Ah, that's better. Thank you, Mike, my savior. I'm bump it up one more time. So let's start over with this. This is a request. This is a request that's being made to my web server. And you're going to see here, this is what we call a protocol, right? So TCP/IP protocols are really cool in that they are they're really cool in that it allows us to define functionality within how we're going to talk over HTTP. So obviously the popular ones are GET, which means get information, POST, which means to post information. You run into others, but the reality is the majority of what we do is GET or it's POST. So getting information means that I can get information, I can put it on the URL. Posting means I can post it and get it, push information to the server. So when we look at how that works, this is a nice little tool that everyone should have. This is called Postman. This is free. It's very, very standard in the industry. I know a lot of people who use this. And so I think this is the easiest way to present what an HTTP request looks like, how it operates, and what it does. I come in here, and this is my action. You can see get, post. I can put patch, delete, copy, head, options, link, unlink, purge, lock, unlock, prop, find, and view. But I'll be honest with you, we use get and post. So this is get, and then this is a URL. And so when I send this, you will see that we sent where's the raw button here? So you can see when we sent it, went it up with a status from the server, and that status brought us back this information. So we sent it a post, or we sent it information using a get, and it came back with some information. And basically this is just echoing back what we're saying. So what does this information mean? Let's start with headers. These headers are definitely an interesting part of what we do. So if I send a request somewhere, there's a way for me to basically tag it and say, I want to add this, or I want to add that to it. And the nice thing about the headers is that they are, they're encrypted when they're sent. So a URL request, you go into a server and you're saying, hey, I need your information. Well, the request to the server that I'm going to google.com is not encrypted, right? I have to go from my server to that server and then define encryption and then exercise my communication over that encryption. Well, headers are not sent until the encryption is actually generated. And that means I can send information in my headers that is private, that is protected, that people can't get to. So there's some things in here that are just basic housekeeping, right? I'll show you one. Accept encoding. Accept encoding tells me that this is a request I'm sending, and it says, it is okay to send me a gzip or a deflate or a BR compressed response. Meaning, if it's a really big file, really big thing, then the server may want to go ahead and encrypt it before it sends it. Or caching layers may actually store it encrypted and be able to send it to you encrypted and never actually have to encrypt it but once. And so that just speeds things up. That's all it does, right? A little bit of compression speeds things up. Our connection, keep alive, that just says, hey, between you and me, we've got this secure thing going on. Let's keep it open for a little bit, right? We can define how long, or we can just say, okay, just keep it open a little bit. Why is this important? Well, let's say you're on the website for your bank, obviously a secure site, and you click on the button. Obviously, you're probably going to click on another button within the next, 30 seconds to a minute. So we keep that line open. We keep that encryption valid for a certain amount of time so that you don't have to go back and forth and go, hey, can I get some encryption here? No, we don't do that. We just go back and we say, okay, we're going to keep this connection alive. We're going to keep the encryption going, and we're going to go ahead and use that same pathway again and again and again, right? So that's what that means. Cookies. This is how we send cookies. Cookies are sent as part of the header. They are sent from the browser to the web server if a cookie exists, and they come from the web browser back to the user. And if you accept the use of cookies, then that's how it goes ahead and adds those things to it. Tokens. Look at some. I'm looking for, yeah. So tokens, some different things can be used. This is just the Postman token. It generates kind of a unique URL for this Postman interface. Authorization. This is a huge one. So there's a number of ways that I can say that I am me, and that's considered authorization, right? I can put a token, a unique token inside of a cookie that I just send. And that's great if you're like on, I don't know, some website where you're just browsing, you're not logged in, you're not worried about it, but maybe you're starting to build something into a cart or something like that. Well, they'll use a cookie to track that who you are, because that's how the functionality of the website works, right? You don't want to put 3 things in your cart, go back to shopping, and the things fall out of your cart. Well, the way we get it to remember who you are is through cookies. Now, when we start looking at after I log in, I may still save the session as a cookie, and on the back end go, okay, this cookie means this person for this long on this computer, blah, blah, blah. But what we often do is we start adding authorization. So that's where we start adding basically an encrypted form of like a password, or like a session token. And that token may only be good for the next day, and then you've got to go back and you've got to go through a process. Like every so often, you're automatically logged out of a website. Well, you may have to go back and re-log in so you get a new token. Authorization is done a number of different ways, and it's most of the time done with one request going to the server and coming back. And that request is your username and password being sent, and then some kind of unique identifier being returned. And once that's done, you take that return identifier and you just tag it on every request beyond that, right? And then the server knows who you are, it's unique, you're identified, you're good to go. That's often how it works. The sites that you logged in often use cookies to do that as well. So they have a session ID and they'll put it in your cookie, and they may say it expires in 30 days or whatever. You come back, it re-ups that expiration. User agent. User agent is really cool. User agent is going to be basically the person doing the call to the website. User agent can be, it's typically something more like Chrome or Safari or Internet Explorer. They get very complicated. They get very different programs can add-ins or things like that can change the way your user agent looks from your own computer. But you know how people are like, oh, well, a ton of people use Chrome, not too many people use Firefox, everybody hates IE, and there's some hardcore Mac people still betting on Safari. And the way we know that is because the user agent tells us what kind of machine you're on, what kind of web browser you're using, whether you're mobile, whether you're on a tablet, whether you're on a PC. And you hope that nobody has fussed with it and nobody has tried to change it, because yes, the user agent is defined by the person making the request. So if I wanted to make myself look like a MacBook when I'm actually on a PC, or make it look like I'm coming from Internet Explorer when I'm really in Chrome, I can do that. I just spoof the user agent. And there's not that much you can do about it from a server-side perspective. Why is user agent also cool? Now, here's another thing too. User agent can also be if I have a unique object out there. Let's say I have a particle photon. And so I can put a particle photon and I can put its serial number on the user agent. And that can identify it inside of web logs. So these are all stored in logs on the server when you access stuff. And now the particle and its serial number is now showing up in my logs. And that allows me to be able to identify, hey, this device is hitting me, and I know it's hitting me because it's in my logs. So you can use that to your advantage. I actually like when I write APIs and stuff from system to system to identify calling one system to another. One system may be authentication, another system may be data store. And so authentication will talk to data store and it will say the user agent is authentication-API. And the data store may be talking to authentication later and it will say data store.API. So you know where the traffic is coming from. And that can be really advantageous, right? So very simply, we can look at, these are really cool. We can look at some very simple GET requests and put requests and posts. GET requests are very simple. They are simply asking for information from a server. They do send some information with the initial request. That information is typically in headers, and those are here. And this is the headers that I'm sending the server. When I hit send, you can see it's coming back. The other part of this, though, is right here, parameters. You've seen these. You probably just don't know what they are. Or if you do, you're just like, oh, this is cool. Jeremy's telling me something I already know, which is rockin' cool. So I can add a header, or I can add a parameter to my URL. And I can say awesomeness max. And I can say lame, not on your life. I can say IoT rocks. All right, now, when I send this, you can see all of these arguments get sent to my server. No, they're not as pretty as this when the server receives them. Yes, there are a ton of really cool applications out there that will make it look this good. So, yeah. But basically what we're doing is we're able to change this information up here, and that information does get sent to the server, right? So why is this really cool? Because if I take this as a URL and I copy it and I paste it into an email, they're going to see exactly what I saw pretty much, right? So this is really cool when you're like on Amazon.com and you want to send your wife a picture of that thing that you want to buy and you want her permission, you want her to say yes. And so you copy the URL out and you put it in Facebook to her and you send her a message, and I hope she doesn't yell at you. And the advantage is now the URL, it'll say like product ID equals 1834, blah, 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 right? And so now I've sent that URL, and that's the only thing I've sent. I've gone up to my bar, I've copied, I've pasted it, right? And then I send it to her, and that product ID on there identifies the widget that I want to buy. And now she can go to Amazon and look at the widget I want to buy instead of the widget I don't want to buy. And so this is where a GET is really, really cool, because these URL parameters allow us to put things in the URL that now become very, very shareable. This is also really cool when you're talking about just wanting to send very, very small bits of information. You're not too worried about them being encrypted. You're not too worried about them being protected. And so you're going to go ahead and send them in the URL itself, and you send that and the server can get it. And it can be a lot easier just to formulate a single line in code than it is to take all of the information and encrypt it and do all of that. So this is really cool. The other thing we look at here, when we start looking at a post, oh, and I should tell you, when you get into URLs, you have something called URL encoding. And what that means is this is actually not being sent this way. You'll see little percent signs in your URL sometimes. So what this actually means is %20 is also the same thing as a space. So I added %20 here, and it added a space in the product ID. So certain things that have to be decoded when you get them. And a URL is one of those. There's a million different applications out there in code that'll do it for you. You just need to remember that it is encoded sometimes. We'll take a look at post, and we'll take a look at two different ways to post information. This is a post, and it has headers, right? So this is where we have our authentication, content length, user agent, blah, blah, blah. Now we introduce the idea of a body. A body is what we're going to send, right? It's all of the information. And this is where we get into really complicated, forms where you're filling out, 32 different boxes to go to that really awesome security conference. And all of that information is going to be in a form, and we're going to post that because we want some protection to wrap around that, but also because, believe it or not, URLs have a maximum number of characters. If you're going to go over about 2,000 characters, you really do need to do this in a post and not in a get. Although, to be honest with you, you can adjust lengths of URLs to almost anything, depending on if your software can handle it, like Nginx, and then the backend software, whatever you set up. Often you can make those changes, but 2,000 characters is probably about the limit for most people, most systems. So when we want to do something bigger, we come in here and we're going to do a body. And what does the body do? The body allows us to put in information and send it. There it is. See, there's our data. And I can send that in a number of different formats. This is just raw data, right? And that's all it is. The other thing I can do is something called form data. And form data is how, you do those forms online. And this data is encrypted. This data is actually set up so that you have different keys. The key would be like the name of the field and the value that you put it, right? So easy enough. So now that we know this, how does this work? What does this do? So let's go to a whiteboard and let's take a look at how this works. So I have a mobile device. I have a server, and let's say this is a touch screen. Let's say that this is a touch screen, and this is a touchscreen thermostat. You put your phone down here. We got a server over here, right? And we got your touchscreen thermostat, right? Your Nest or your whatever you want to call it, right? So what's going to happen is your thermostat is going to be sending to the server the temperature. Obviously, because the server wants to know what temperature your stuff is at, right? It's also going to send information like running, right? Because now data mining your thermostat is making Nest a lot of money. So they want to look at usage stats. They can figure out how to make not only the experience better for the users, sell to different companies who want to use that information. But also, it's great for helping you because now it allows you to share with them how your system's running. And at some point, I'm hoping that these thermostats will start telling you things like, hey, you're low on Freon, or something's wrong. It's 90 degrees outside and your house is 87 and we've been running the AC all night. We've got a problem, so we're getting to that point. My train system does that, by the way. Huge, big, furry, manly train system. Will actually tell my dealer, hey, there's a problem with Jeremy's system. We need to fix it, right? They don't have to hook up connectors to it. It'll actually tell them how much Freon is in my system, right? What the pressure is. So those kind of things are being pushed back to the server, right? And we can do those. We typically do those over a number of different connections. But if we do them over an HTTP post, the post would likely send a request using tcpip, and that information would likely be in some kind of format in the body, and it'd be posted back to it. And then what happens is from the server, our phone can talk to the server. The first thing the phone is going to do is going to send a request to the server. Hi, I am Jeremy. And it gives you you give it a unique ID, which is basically your passcode that you were given earlier when you logged in, right? So send that off to the server, right? And then the server comes back and it says session ABC or whatever, right? So it gives you that unique identifier that's only good for a little while that you can use to talk back and forth to it. And then from there, you can start talking back and forth from the phone, right? So the phone can say, hey, what's the current temperature, buddy? And it says, hey, it's 42 degrees outside. It's, 80 degrees inside your house. Your system's running, your fan's on, and, this is how long we expect it to be running. This is how much it ran this today, and all of this information. So, yeah, so it gives you all of that. When you're talking about these commands going back and forth, right? You're going to have some kind of request. Some kind of request. Then you're going to have some kind of response. And this request is normally going to have a post or some data with it. And the response is normally going to have some kind of return data. So this is your server. This is your iPhone. Right. So I'm making a request using a post. I'm posting the data there. I'm getting the response and pulling that back out. Now, when I actually see this in works, let's show you some cool stuff. So let me pull something up here. For those who don't know, Arduino does have an online toolset. It's a lot better than Arduino Studio. However, to my dismay, it does not handle very well some processors like the AT-Tiny85. So it's a cool tool. It's not bad, but This is actually production code. This is code that's running right now on devices. There's a device on my desk. It's actually running. And the reason I want to show it to you is because it shows you very cleanly. This is a TCP post, and it's pushing data. And so you can see the first thing we're doing is we're actually connecting to our server. We're using a port number. Why do we have a port number? Servers have addresses. Cool. What if you want to run two things on the same server? They need different ports. Think of it as an apartment building and an apartment number. Or think of it as I've got 5 USB ports on my machine, and I identify a single USB port, right? USB port 2 is where something's plugged into. Port numbers can be, by the way, 0 to 65536 or 64K. So 0 to 64K, well, 64K minus 1. We always number from 0 on. We are going through, and you remember how we had, and let me split the screen. Hey, you know what? Let me change that. Let me change that screen. All right, so cool. So this is actually production code. We're going through here, and we are putting, as you can see, you can see the post, right? So if I was doing a post, instead of get, it would say post here. And then it's saying the path, right? The path is lambda MB 1500 underscore target. It's telling us it's transmitting HTTP protocol, right? It's telling us what the host is. So it's printing out the host, and then it's saying what the server name is. It's telling us to keep that connection alive. Remember, that's the, oh my gosh, I want to make sure that this connection stays alive because I want to reuse it sometime. It's telling us the content type. This tells us what format the data is in. No, it doesn't have to be right. It should be right, but it doesn't have to be right. The content length, right? So we generate some data here, up here. We're actually pushing some data. So obviously a system key and some information about a site and signal strength, my carrier, all that information is listed here, right? So when I get down here, I'm measuring the size of that data right here, and I'm putting in there what the data length is, right? So data length is a number. And then I print a blank line, just like I did here, right? So just like there is here, blank line says, I'm done sending information. Now send me information. That blank line comes back, and I go ahead and push my data, right? And then I say, here's my data. And then it responds back. And I'm obviously ignoring the response here. Maybe I shouldn't, but I am. All I do is I delay for 100 milliseconds, and then I just drop the connection. So is that the smartest thing to do? I'll be honest. By the time this has been transmitted, if it's wrong, there's not enough time to retransmit it. So the opportunity's over. You don't have any ability to retransmit it. So you just wait for it to loop again and retransmit that way. Is that the best idea sometimes? Depends on the use case. It really does. If you're sending information from your Nest thermostat, you're sending your temperature, and you're sending information like whether the fan's on or not, and you're sending it every minute, do you think it matters if 1 out of 2 minutes is missed? Probably not. So there's a reliability aspect in what we send and how we send it. So, Michael, hello world. Yes, hello world. So that's a real world example of an HTTP request. When we're looking at different kinds of code on the back end, there's a lot of ways to handle these requests. As you can see by my example, yes, I'm actually using a Lambda to respond to this microcontroller. So this microcontroller, it's an MKR 1500, which is basically a particle boron, but made by Arduino. A little bit more expensive, just different flavor of IoT device. It has NB-IoT, so it's pretty easy to rock and roll on it. And so this is HTTP protocol. So this is what's behind the scenes. This is what we're looking at on the back end, right? On the front end, all this stuff does really cool, pretty stuff like this is HTML. So this says I'll have to document my header. This is what shows up in the header of the web. So Arduino editor, right? That's the header. That's what this title means. Background should be white, obviously. Center a large number. This is 503. And tell them it's the end of the body. Tell it's the end of the document. And then I'm going to close the connection. Okay. So, and so that makes, one full turnaround from us to the server and back. So, this is basic TCPIP. It gets really complicated really quickly. The biggest thing to remember is you've got a difference between get and post. What's the difference? Get typically gets information. It can send a little bit, about 2K. You can increase that by using headers a little bit. It allows you to take that URL and copy and paste it to somewhere else. So if you wanted to be able to take that URL and send it to your wife and tell her what nifty gadget you want her to buy you for Father's Day or whatever, you can do that. Whereas post is definitely designed for pushing data in a more secure fashion that typically tends to be larger in size. You mentioned a browser-based setup tool equivalent to Arduino Studio. Yes. This is Arduino Cloud. This is awesome. This allows me to write code, and I can save it to the cloud. And you can see I've got some samples up here. And this is some really cool stuff. So this is actually code that I've been playing with and working with. And there's an agent that sits on your machine, and that agent allows you to communicate with the Arduino over serial connection. One of the hugest advantages of this is for certain devices, not all devices, for certain devices, this means that I can open up Arduino Studio. I can type in my code. I don't have to worry about, there's a lot of things already included here, right? So a lot of common Arduino libraries are already loaded into this environment. I just reference them and it pulls them. There's also a really cool monitor, serial monitor. So if I take a device and I go ahead and have it sending serial output for debugging, I can click on a serial monitor. I'll be honest, when I'm in some hardcore work, I use TerraTerm. Why? TerraTerm will automatically reopen a connection for me when I'm running, and it for long running items, like stuff I'm running for days testing, I can leave TerraTerm up. It will automatically reconnect. For example, we have a watchdog timer on this project, and that actually resets the entire processor. When that happens, you lose your serial connection, and so it has to regenerate that and recreate it on the PC. It's like pulling the USB cable and plugging it back in. TerraTerm will actually reconnect automatically, right? And so that's kind of a nicety of that. It'll handle multiple different boards. The only thing I'll say is if you pay for it, it handles the ESP8266. No ESP32 support. It's got the ability to push code, do over-the-air programming to the MKR 1000 Wi-Fi and the MKR 1010 Wi-Fi device. I do not know that the 1500 supports it. It may. It's still a SAM21 device, so it could. There's a ton of examples. It's just a really cool user interface, and another really cool thing. It's not that expensive, although I think it should be free, but it isn't. They give you $30 credit against an order when you pay for your first year, and the software I think they get you for like $5-6 a month, so it's not too bad. Yeah, so as opposed to Particle.io, build.particle.io, which is Particle's online IDE. They both have some problems. Don't open code in multiple browsers, because the last browser you touch is the code that it keeps. There's no rollback capabilities in a lot of these tools. There's no GitHub. There's no, versioning. So it can be very dangerous to operate in these environments. I do copy code out quite a bit and make sure that, or download code quite a bit to make sure I have a backup copy. Do it about every night when I am done working. So other questions, projects, things that you're working on, cool things that you've seen? Awesome. Well, I want to thank everyone for coming out here tonight. Want to remind everybody of a couple things we've got going on. So just a reminder that Riot is holding their developer month starts September 2nd. These are going to be basically half-day events, all virtual. They're going to be really, really cool, really fun. I will be speaking, I think, on week 3 about reliability. There's going to be a lot of other really cool discussions. Definitely think you should join us. I think it's just going to be a ton of fun. Special thanks to our sponsor, Pratt Miller, Dan over there doing some really cool stuff with machine learning. And just a reminder of the virtual the Cyber Security Summit here in Charlotte. It's for executives in the Charlotte region. Like I said, there is nothing better than sitting in the back of the room with a bunch of executives, listening to how they think, listening to how leadership thinks about security and reliability and how they want to move forward. Listening to those discussions, I can tell you, will make you smarter when you're talking with these people, because you get to understand all the interesting things they really want to look at. And I think it's going to be a really cool event. They're going to have a lot of different people talking about a lot of different subjects. I'm really interested in some of the IoT stuff going on. It's definitely designed for senior people. But want to make sure that love my office. Yeah. Love my office too. So anyways, definitely stop by there. Thank you everyone for coming by. Thank you, Michael, for the shout out of the office. Yes, if I can put it in this room, I can own it. That is the rule of the house here. So you can imagine I've gotten very good at organization. So thank you everyone for coming out tonight. If you got any questions after this, feel free to post them on the URL on the link, and we will definitely answer them. I will be posting some show notes at the end, give you some things to think about, and definitely appreciate everyone coming out. If you got ideas for the next meetings, you got projects you want to show off, something you want to talk about, let me know. We'll definitely get you online here. We can bring people in and out with this cool tool we've got. So it's not just me alone. We can have other people broadcasting here. If you missed it last week, we did AWS Greengrass. That presentation's up on YouTube. And everybody have a great night. Thank you for coming out. And we shall see you in 2 weeks. Thanks. Bye.